Hi, I'm Max Dalton, and in this video, I'm going to talk through how to build a schedule network diagram. Understanding the basics of what goes into a network diagram and then how to create a basic network diagram are critical to passing the Project Management Professional exam. This video walks through these basics, exploring everything from defining activities, estimating activity durations, sequencing activities, and finally, building a simple network diagram. And now, the steps to build a schedule network diagram. The first step to building a schedule network diagram is to define your activities. Defining the activities associated with your project is best done when working from the work breakdown structure you should already have, as you should already have defined the high-level deliverables and work packages. Defining the activities for your project requires decomposing those work packages one step further into blocks of work that can more easily be used for generating estimates and scheduling the work. The key outputs of defining activities that you'll need to know for the PMP exam are an activity list and activity attributes. The activity list contains the work breakdown structure ID associated with the activity, activity name, activity description, and ultimately the names of the resources associated with working on an activity. The activity attributes document contains the work breakdown structure ID, activity name, activity description, and ultimately the predecessors and successors to an activity, the relationship to predecessors and successor activities, and skill requirements for that activity. Now that we have our list of activities and an understanding of the work associated with those activities, we need to estimate the work durations associated with those activities. There are three primary approaches you'll need to be familiar with for the PMP exam when it comes to estimating activity durations: analogous, parametric, and three-point, or PERT. An analogous estimate is when you use the actual information associated with a past, previous effort as the basis for the efforts associated with your current effort. For example, if a similar activity for a different project took you 8 hours, you could use that as a foundation for estimating that this activity will take 8 hours. A parametric estimate identifies a variable or unit within another project effort that can be scaled to estimate your current activity. For example, let's assume you're generating an estimate to build 6 miles of fence. Last summer, it took you 1 day to build 1 mile of fence. As a result, you could then make the assumption that it will take you 6 days to build 6 miles of fence. A three-point, or PERT estimate, takes the best, worst, and most realistic duration estimates and plugs them into a formula, weighting the most realistic estimate more heavily. The formula to generate a three-point estimate is optimistic plus 4 times the most likely duration plus pessimistic divided by 6. Now we can move forward with sequencing our activities, which is where we'll understand what the predecessors and successors are for our activities, the relationships between activities, and what the sequence of activities should look like. The first step to sequencing your activities is to understand what activities are dependent on other activities. Note activity dependencies in the predecessor part of the Activity Attributes spreadsheet. Now that you understand all of your activities and their dependencies, you can move forward with sequencing your activities. Open a spreadsheet where you'll build your network schedule diagram and create 3 columns in the upper left corner with the following column heads: activity, predecessor, and duration. Start by listing the activities in the order that you feel it makes the most sense to work through them, based on the information you've gathered in the activity column. Then, plug in predecessor and duration information for each activity. Review this to make sure there are no conflicts with the order of the work. The final step before you can begin building your network diagram is to document all of the instances where activities have relationships with another activity in the Activity Attributes document and call out what type of relationship that is. For example, if activity B is a predecessor for activity C, that would be a relationship between those activities. The next thing to determine is what type of relationship those two activities have. There are 4 types of relationships that activities can have: finish to start, start to start, finish to finish, and start to finish. A finish to start activity relationship is where the predecessor activity must start before the successor activity can begin. This is the most common type of relationship. It should also be noted that if you find yourself in a situation where you'll need to explore fast-tracking your schedule, these relationships will offer the greatest opportunity to get back lost time in a schedule because they are not built with any overlap. A start-to-start activity relationship is where the predecessor activity must start before the successor activity can start. A finish-to-finish activity relationship is where the predecessor activity must finish before the successor activity can finish. A start-to-finish activity relationship is where the predecessor activity must start before the successor activity can finish. This is the least common type of relationship. The next step is to move forward with taking our information and creating a schedule network diagram for our project. This can be done in Visio, Excel, or a variety of other applications. Begin by creating a start box at the location where you want to begin building your network diagram. Then, make boxes to the right of the start box for each activity with no predecessor activities. Put the ID and duration for each activity in its own box. Draw an arrow from the start box to each of the activity boxes. Repeat this process until you have drawn all of your activities, and then have the final activities point to an end box. This is the network diagram for your project. However, there's still a little bit more work that needs to be done. The final step is to identify all of the activity paths through our network diagram, and to use that information to identify the critical path, which is the longest path of activities that runs from start to finish through our project. You identify each path through your project by writing out every possible path that runs from start to finish through your schedule network diagram. After identifying all possible paths, add up the duration for each path. The path with the longest duration is the critical path, because there is no float for any of the activities on that path. As a result, if any of those activities are delayed even one day, the project schedule will be in serious risk. Also, it's worth noting that you can have more than one critical path. After identifying the critical path or critical paths, change the color of all arrows associated with routing through those activities on the critical path to be red so that you can clearly see them.